Okay, today we're going to be working on Chapter 11, Lesson 5, Interpreting Data. And the goal is to make conclusions about populations using surveys. Today's vocabulary is margin of error. Margin of error of a random sample defines an interval centered on the sample percent in which the population percent is most likely to lie. Now, sometimes they lie on purpose. Sometimes they accidentally lie. They just answer it and don't want to feel like they don't know anything, so they'll just answer it like they know what they're talking about, and they just guess. So we have a margin of error due to the people that lie. All right, let's move on. First example, making a population prediction. Now here we're talking about a tennis industry, and they wanted to know, they surveyed 100 Americans, or excuse me, 1,000 Americans, right? Out of those 1,000 Americans, 62 of them said that they played golf 4 or more times in the past 12 months. Now, all of these Americans had to be at least 12 years old or older. So, what percent of that 1,000 played tennis 4 or more times in the last 12 months? 62 out of 1,000 is our fraction. Now, even without using a calculator, say that, what would it be? 62, louder, 62 as a decimal, 62,000. There we go. Get our lift in there. Our 62,000. So we can write that as that 0.62 or right, 0.062 is our decimal. Take it times 100, and that will equal 6.2%. All right? So 6.2% of those 1,000 Americans played tennis 4 or more times in the last 12 months. All right, so on your calculator now, they want us to figure out, well, we figured out 6.2% of the 1,000, but they want to know what 6.2% of the 237 million Americans there are that are 12 years old or older. Now, how did they come up with this number? How do they know there's 237 million Americans that are 12 years old or older in the United States?
The thing, you know, where they do
census.
the census.
The what? The census.
Census.
Yeah. It's a census, when they do the census and they find out the population. So they use those numbers. Now, some of you know how to use your calculator, the percent key. Sometimes you have to hit the percent key, 6.2, and other calculators you have to hit 6.2, the percent sign, and that turns it into, sometimes the percent key is used as an equal sign. I mean, you got to know how to use your calculator, the function on it. They differ. But anyway, if you're not sure how your percent sign works on the calculator, can I just take 6.2 times 237?
Yeah. No, 237
No.
million.
You can't take this, if you don't know how to use the percent key, you have to turn it back into a decimal. So instead of taking it times 100, now we would divide it by 100 or move the decimal to the left twice. And then you're going to take 0.062 times 237 million. How many is that? What do you get? Round it to the nearest tenth, please.
146. Oh, that's not good.
What do you get? Round it to the nearest tenth.
14.7.
Yep. Nice job. 14.7. Is that percent?
Yeah. No.
No, it is not percent. We just figured out 6.5% of, because times is always of in math. So 6.5 or 6.2% of 237 million is 14.7 what? Not percent, but 14.7. Yes, nice. Million people. that are 14 years old or older. Or 12 years old or older. All right, questions on that one? So on your worksheet today, you have to do both that. You have to first find the percent of the sample they took. Find the percentage of the sample they took, and then take that percentage times the total, the whole population, not just the sample. Okay? So you have to have two answers on your worksheet today. Now this example goes along with our margin of error. It's kind of a nice time to have this. We just had the election. And how close was the election? Who was the election for our president between? It was between, who won?
Romney and Obama.
Who won?
Obama.
Okay, so let's pretend that these candidates that we're talking about are Obama and Romney. Say candidate A is Obama, B is Romney. All right? Now, and this is true. I mean, this candidacy, the election, it would change all the time. They'd say, oh, Mitt Romney's ahead in the polls. Oh, now Obama's ahead in the polls. Oh, it's too close to predict. Oh, this poll said that Romney should win by blah, blah, blah. Okay, notice how it changed because it was such a tight race?
Did Obama win?
Well, yes, it did. Okay, these are just predictions they were making before the election. So, let's say this was in the month of June. All right, they took this sample, a random sample of voters. Now, in that survey, 53% of the votes went to Obama and 47 went to Romney, because obviously that adds up to 100%. Now our margin of error on this one, on that survey, is 4%. So let's do Obama first. So he had 53% of that survey. So 53, let's minus that 4% error. What do we get? 49%. And then we take our 53 and we add the 4% margin of error and we get 57%. So Obama's range was anywhere from 49% all the way up to 57% of the votes. That was Obama's range. Now what was Romney's range? Romney was 47% minus 4 is?
43.
Yes, 43%. And then let's add the 4% to his 47 and we get 51%. So Romney's range was from what to what? 43% to 51%. Now, on this survey, could they predict a winner?
Yeah.
How many of you think they would be able to predict a winner? How many of you think they will not? Now, so therefore, on this survey, say it was done in June or whatever, the answer is you cannot. You cannot predict a winner. Now, who can tell me why? Who wants to take a guess?
Because his is 49% and his is 51%. So if Obama is like 49%, Romney can still win with 51.
Exactly, and there's a word that we use for that. That's exactly right, because they share numbers, don't they? What numbers do they share here?
49.
49.
51.
49 through 51 are the numbers that they share. So there's a word. If they share these, it starts with an O. Because the intervals, yes, excellent. Overlap. Okay, since they overlap, you cannot predict a winner. It's too close to call. How about on this one? Say this one was done in October, right before getting closer to the election. Obama will be A again, and Romney will be B again. So Obama is what, 54? Romney is what? They predict 46% this time. And what is our margin of error? Is it 4 again?
No.
They've changed it. Our margin of error now is 3. So what is 54 minus 3?
51.
Minus 3 is 51%, 2, and then what do we get plus 3? 57. So his range is 51 to 57%. Okay, let's go to Romney. What do we get when we subtract 3 from Romney's? 46%. 43% minus, and add our 3%. What do we get?
49.
Yep, 49%. Make sure you always add and subtract from the originals. Okay, not from the new number. All right, what do we think? Yes or no?
Yes.
Yes.
Who says yes? Impressive. I agree. Yes. Why? We can say yes because they do not what?
Overlap.
None of them overlap. This one goes to 49, and then there's like number 50. Nobody has 50%, and then it goes to 51. They share no numbers. Nothing overlaps. So yes. Who should win?
Obama.
Yes. Obama. I can't spell. Should win. That is our prediction, and that one. We could make a prediction on that one.
And it came true.
And it did come true. Question.
What's the O, A, and R?
Well, this was Obama, I just abbreviated. And this was Romney. He was our B candidate.
Oh.
Our A and our B. All right, our A and our B. Okay, next one. Okay, the last part for summary of data analysis. When reading the results of a summary, consider the following. First, identify the population and the sampling method. We know how to do that. Determine whether the sample represents the population. Determine whether the survey questions are biased or not. Identify the margin of error. And then determine whether any data displays are potentially misleading. And then finally decide if the conclusions are supported by the data. Let's practice that on the last example 3, interpreting this newspaper survey. And it says, larger families more likely to own a dog. A recent survey of 1,012 American households by telephone found the larger the family living in the household, the more likely that the household has a dog as a pet. Each household was asked if they owned a dog. The results are shown below. Now, what kind of a grade would I give this? What kind of a graph is this?
Histogram.
Histogram. Yep, the bar graph histogram. Let's see.
Can you give it like 75? Okay.
This is the histogram because we have frequencies and intervals, all that good stuff. Bar graph. It's got the titles. Looking good. Except for they have gaps between. I don't like that on
That's
mine.
what I said, about
Yep.
7,500.
All right, so now, up at this one. Sample is not truly, what do you think? The sample is not truly, what kind of sample did they say they had?
Unbiased.
No, what kind of sample did they use?
A household.
No?
Survey.
Which one of the techniques? Which technique did they use?
Oh, the
Systematic.
Systematic?
No. Wait a minute.
No? No?
not random.
What's it say right here?
Self-selected.
Stratify.
How do we know this?
You guys said I do. Yes, no.
What do you think?
Self-selected.
Does it really tell us?
No. Exactly.
So what should we go with? What we think they would probably use then?
Self-selected.
Self-selected?
I would think random. I would say random. No. Because
Well,
they call some people.
It's not truly, it's not random. It's not random because only American households with Phones could be surveyed.
Oh, you have those box.
Now, how about the question that they asked? Is it biased or unbiased? Each household was asked if they owned a dog.
Unbiased.
Not biased or unbiased. Same thing. The graph is or is not appears to be misleading.
It does. It's not.
Right. It does not appear misleading. There's no broken vertical axis. They start at 0. They've got everything they're supposed to have. Is the margin of error given?
No.
Margin of error is not given to us on that survey. List of household sizes is what? Do you think that's a good number to give us? We had people with 1 person in the house, 2 people in the house, 3 people in the house, and 4.
No.
No, I think
It should be
So
like
it's pretty, it starts with an L.
it should be like 3 to 5.
Lousy?
Lame.
L-I?
Linear.
L-I-M?
Limbo.
Little. It is very, you like to shop at this place, the mall, the limited. Okay.
I don't like this shop.
Okay, I made it up. I was just trying to find you a hint.
Yeah, I was like, what?
All right. So those are the fill in for those boxes.